Hello everyone, this is the video lecture for Calculus 1, Section 3.1, Derivatives. And in specific, we're going to do power and exponential functions here. So what does that mean? Well, it means that we're actually going to do calculus. So this is the actual calculus side of things, I suppose you could say. Let me show you the power rule. So power rule, and it might be a little weird at first, and I'll explain it as we keep going. D dx, that's still a division, we just don't say d divided by dx, it's too much words. D dx of x to the n power is equal to n times x to the n minus 1. All right, so we're good now, right? What is going on here? Let's talk about a lot of this notation and we'll keep moving. D stands for derivative. Wow, really? The dx here in particular is saying in terms of x. So they're saying that we're doing x's basically, and that's very, very typical. This is our function right here. I guess you can call it like your f of x in a way. And this would be the result. Okay. So we're basically taking this thing and going to this thing over here, and that's what a derivative is. Well, the process is actually really easy. We're going to take this n power and move it down to the front. And then you subtract 1 from the power. So here's some English, I guess you could say, is bring down the power and then minus 1 from the power. There you go. And I'll be saying that a lot today because that's what we're going to be doing today. All right. This works for a lot of basic polynomial stuffs. So let's do some examples of what's going on here. Let's say that I got x squared. Let's say y equals x squared. This is a classic problem right here. So if you want to do the derivative of x squared, then it's just going to be a 2x. And that's the answer. But really, what was going on is that the 2 came down to the front, and now it's a 2 minus 1 power. Well, 2 minus 1 is a 1, and we don't really have to write the 1, so there you go. Let's do another one. So let's say that I'm trying to be proper, I guess you can say. So we got x cubed, same kind of deal. I'm going to take the 3 and move it down to the front, and now it's going to be a 2 power. That's good enough. I mean, we could do it like, 100, x to the 100, to the 100 comes down. Now it's 99 power. That's all it is. It's a very simple idea here, okay? Cool. So let me tell you a little bit more about notation as we go forward. We had seen in the previous sections, we saw g prime of a, g prime. That's a hint towards a new style. I guess what you can say is, let's start with this y equals x squared. There's a couple ways you can redefine it. You could say y prime is 2x, so that's your derivative. The little prime means that you took a derivative to get there. And so, like in a weird way, we could kind of mix these notations and say, there's my original, and then now I have a derivative. So you went from the original to the derivative. I'm trying to show you these notations because they're going to mix them up. You're going to see the d dx, you're going to see the f primes. Kind of just depends on how they're feeling at the time. This f stuff, this is Newtonian, while this d dx stuff is Leibniz. If I could spell it right. I think it's a TZ in there. Leibniz. Okay. So they're both the same thing, but they have different strengths. And as we go much further, we'll be doing multiple derivatives. So then you got 2 derivatives will be 2 lines, 3 derivatives, but 4 derivatives is apparently too much, and people start just putting a 4 and then a 5 and all that. So Newton has its limitations, where Leibniz would have something more like this here. So that's your second derivative. third derivative, and all that. And there's a lot of strength to this later when we're going to be doing, say, like implicit differentiation, which I think is another few sections away. So I just want to kind of teach you both notations here. D stands for derivative. Prime stands for derivative. You'll see both, okay? But ultimately, what are we going to do? We're going to do this power rule. Let's do some examples now. And I really don't like question number 1. I'm pretty sure this is question number 1. I don't like it because it's trying to be trickery, and that's not cool. Not on the first question, at least. Even though it is very simple. Let's start over there on that. Okay, so this is my original function. They say, hey, find my derivative. All right, well, normally you'd say, oh, the 60 comes down and all that stuff. That is not the case because this is 2 to the 60. This is a constant. This is a constant. And the derivative of a constant is 0. And I guess I could prove it to you, but not with 2 to the 60 because that's just too much. But think of it just like it's just a number. The derivative of a number is just 0. So let's do that. I guess I want to do the next problem, and I want to show you why that happens. For right now, just put a 0, and that's okay. Let's do g of x is equal to 3x plus 2, and they want to find g prime of x. I mean, this is a classic easy problem here. Well, the answer is 3. Yep, that's all it is. But why? So let's do 3. This is 3x to the 1, and this is 2x to the 0. And now I'm going to take its derivative here, okay? And so the derivative of this would then be the 1 comes down to the front, 3 times 1x to the 0, right? 1 minus 1 is 0. And then the 0 is going to come down to the front. And then you got x to the negative. So that x to the negative 1 is a lie. This is not real. This is nothing. I just want to warn you, don't go thinking that you should be doing this every time. Bad math. But it's a point to it, though. Thing behind this that we need to talk about, of course. And so looking here, anything to the 0 power is a 1. So you're doing 3 times 1 times 1, which is just going to be a 3, right? So that's easy. But on this side over here, anything times 0 is a 0. I don't really care what this guy is because it's 0. So 3 plus 0 is 3. There you go. Don't really do this. If you see a constant, this 2, the constant goes away. That's it. Just make it equal to 0. So I kind of half proved it to you. I don't like that. Don't do this. Just make constants go to 0. Okay? It's way faster anyways. Cool. There was one other thing I wanted to talk about. Oh, yeah. So let's just look back and forth between this guy and this guy. What's the relationship between these two? If this is my function, then what is this number? And you could say, it's the number in the front. Yeah, but there's more to it. This is an mx plus b line. You're talking that's your slope. And so your derivative is actually equal to your slope at any particular moment. Okay? If that's the case, if we had a flat line, again, this is a constant function, then I'm going to say, what's the slope of this flat line? Well, the slope is 0, isn't it? And that's how they're getting that as well. Okay, let's keep cruising. 31006. Like, now we can actually do real math. So now that the goofy questions are out the way, this is a nice solid question right here. So f or g or whatever, doesn't really matter. What's the derivative? 2 comes down to the front. Now it's 2/6 times x to the 1. And then this, again, is a 1. You can make it come down to the front, or you could just say it's the number in the front. That makes it easy. And then the constant goes to 0. And so you actually end up with 1/3 x minus 4. And there you go. Very, very fast, very simple and easy. How I often think about is this stuff right over here is my line. That's my mx plus b stuff. And so I just say, well, the answer right here then is just m. And that's it. It makes it way faster. You don't have to think about it. All this other power stuff, obviously you could just move the power down and get rid of one of those powers. 310 0.019. All right, so f of x is equal to x cubed times x plus 6. And they say, find the derivative. There is definitely ways to make this happen without simplifying, but what they're trying to imply is that right now we should simplify. We should try to distribute. And so then when I take my derivative of this, that's going to be 4x cubed plus 18x squared. 3 times 6 is 18, right? Yeah. Yep. Cool. There it is. That's it. Very simple. Bring it down, multiply it, simplify it if you need to. Done. Very simple. Next question. Capital F of R. I love it when they do this. Why can't we just use X? You know what I mean? So what's capital F prime of R? Whatever. So, yeah, how do we fix this thing? So what I want to do is, first off, I want to rewrite it so that it's like this guy. That's actually a -3 power. That helps so much because I don't know what to do here, but this is much easier. So I'm going to be bringing that -3 down to the front, and then I'm going to -1 from the power. You're not making the numeric less. You're not saying, oh, well, it's now a -2 or something. No, 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 no. You are -1 from the power. You had a number, -1. So then what do we really have is a -4 now. And that's good enough for WebAssign, obviously. If you want to redo it, that's also cool too. They're both fine. Remember that it's R. Remember that it's an R. Don't type X. I do not like when they do these new letters. I mean, I kind of get the point, but who's going to use R? So I've got 7th root of t minus 7e to the t. What's the derivative? So this is a little different here. Notice that we got an e to the t, so I've got to give you a formula. So d dx of e to the x is e to the x. Wow, really? I mean, yeah, that was it. Ta-da, formula. Your derivative of the e to the x is e to the x. It doesn't change. This is actually a really neat little function formula thing, and we'll be using this forever. And so we like e to the x. Now, this does not apply to 2 to the x. Is not just 2 to the x. That's not the truth. This is another formula using logs and all this other stuff. And so I don't like that personally. I can't remember the formula right off the top of my head, but I certainly remember this one because it's really easy, and we like that. So good. Let's just keep that, I guess. So my derivative, this guy right here first. Whoa, I don't want to do an equal sign. I just want to bring this guy down. So this is technically, this root is 1/7. And so then I'm going to bring the 1/7 down, and I'm going to -1 from the power. This, of course, doesn't change because my derivative e to the t is going to be an e to the t. Now, how did I go from 1/7 to -6/7? Well, I basically just said -1. So that would be 1/7 minus 7/7. And if you do the math in the numerators, it's a -6/7. This is good right here. You do not need to do anything else. This is WebAssign. You do not need to do anything else. Don't. It's not worth it. Next question. 31021. We got y is equal to 6e to the x plus 5 over the cube root of x. Find the derivative. This is actually not too bad. Obviously, this e to the x is not going to change, but over here we got a 5x to the -1/3. Pause for a second. See how it's in the denominator? So it's negative. See how it's a third root, cube root, third root, so it's 1/3. And so then my derivative is just going to be 6e to the x. Again, just doesn't change. I'm going to bring this guy down to the front, so it's going to be a -5/3 x to the -4/3. Again, I do not know of any reason why you would want to simplify that. Just type it in and get it done. Like, if you simplify it and start using roots and stuff, like, you'll have to click those root symbols and everything when you could just type it so much faster this way. But that's just my personal opinion. Now, this problem here, I did differently on my notes than what I'm going to show you here. And they say find the derivative. So let's just say I'm confused because e to the x, cool, but e to the x plus 6, I don't really know. What they're wanting you to do instead is to break this down as e to the x, e to the 6 multiplied. And the reasoning behind that is that you got your bases are multiplied, which means your powers are going to be added. And so this is what's really going on. But e to the 6 is just a constant. So that's just a constant. The only x going on is right here. And so when I do my derivative, I got e to the 6, e to the x, because the number in the front stays the same. E to the x goes to e to the x, super easy. And then 3 is going to go to 0. Now, you could just rewrite this back in its original format, or you can leave it like that. Whatever. On my notes, I did something a little bit more advanced. I jumped ahead about 2 or 3 sections, but we'll do that later. So 31033. I've got a big one. P of w is equal to 8w squared minus 2 times w plus 6 all over the square root of w. And they say, figure it out. Well, there is a way to do it as you see it, but personally, I wouldn't want to do that anyways. So I'm going to distribute my denominator. Everybody gets a square root w in their denominator. So you get a square root w, you get a square root w, and you get a square root w. Well, in the bottom, that's technically a negative 1/2. And so what I actually have is a 2 power and then a negative 1/2 power. Oops. I have a 1 power and I have a negative 1/2 power. And then here is just a negative 1/2 power. I know it's kind of tiny. I'm sorry. Okay. So I'm going to multiply my bases together, therefore add their powers. And what you actually get is now w to the 3/2. Here we got, when you add 1 minus a half, it'll be actually just a positive half. And then here we got a negative half. This is my original. That is not yet my derivative. So, yeah, now we need to find a derivative. And so I'm going to bring this down to the front. So 8 times 3/2 w, and then I'm minusing 1 from the power makes it actually just a positive half. The 2 gets a half in the front, and then now you minus 1 to make a negative half. And then the 6 now gets a negative half in the front, and it's going to be a negative 3/2. This is your answer. You can simplify it. I mean, obviously there's ways to make it look a little bit more pretty, but there's no real need. I'm going to leave it. Type that. 31053. So I have s of t is equal to t cubed minus 12t. And then they say v of t is equal to what? And then a of t is equal to what? So what they're wanting to talk about here, I'll just go ahead and do it. Velocity, and then acceleration. I'll just put accel. We got velocity and acceleration. Well, this is very simple. This is s prime, and this is s double prime. Basically, I take one derivative, and then I take another derivative, and there you go. This is not hard at all. So let's say I've got the t cubed minus 12t, and then I take a derivative of it. Notice that I just did it. This is like really rough Newtonian form, but it does still work. This is still a legit way of expressing what you want to do. So whatever we got, prime, and so then I'm just going to take the derivative of it. And so that way I would have a 3t squared minus 12. Again, there's a 1 power, the 1 comes down, 1 minus 1 is 0, and so then it's, anything to the 0 power is a 1, and all that stuff. Again, it's easier just to see it as a slope. Makes it very easy. Well, this is your answer for your velocity. But then I'm going to take it, and I'm going to find the derivative again to find the acceleration. 2 comes down the front, makes a 6t. The 12 goes away as a 0. There you go. There's your acceleration. That's it. I don't know. 3 1059. I got y is equal to x cubed plus 3x squared minus 9x plus the 6. And they want to find the horizontal tangents. So what does that mean? Well, whenever you have a graph like this, they're wanting to know where is the tangent line going to be a horizontal, something like that. And so what they're actually looking for is maxes and mins. Maxes and mins. And so where's the tops of the hills or the bottom of the valleys for something like this. And this cubic, you can see right here, positive cubic, it will look something kind of like this. So we're looking for two answers in particular. But how do we find that? Well, it's very simple to find. It's going to be my derivative equals 0. That's it. Solve for x. Like, that's the procedure. So we got y prime would be, again, my derivative here. I got my 3x squared, 6x minus 9. Again, just moving them down to the front, slope, that kind of thing. Set it equal to 0. Well, I need to solve for x now, and there are many ways to do it, but I think I could see that they're all having a 3 in common, which really helps so that I can actually just factor this now. Plus 3 minus 1. And so we got two answers at x equals a negative 3 and x equals a positive 1. And that should be good, but what we really need is, to format it to what WebAssign wants. And so what WebAssign wants is for you to take these values and then plug them back into the original. And so we had our original was x cubed plus 3x squared minus 9x plus 6. Well, I need to plug that negative 3 in wherever I see stuff. Plug it all in, and blah, 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 calculator, and I get a 33. Same thing over here. I'm going to plug in the 1, and so I got a 1 cubed plus 3 times 1 squared minus 9 times 1 plus the 6. Scroll over a little bit, plus the 6. Putting all that together, I got a 1. And so my two answers should be then negative 3 comma 33. And then my other answer is a 1 comma 1. However they want that format, I can even tell you, because I know what the cubic looks like, right? It looks like this, that the first one's a maximum, and that the second one's going to be a minimum. So this guy must be a maximum, and this one must be a minimum. And by max and min, obviously, I mean relative maximum and minimum. But that's for a whole other section. So it says we got p of x is equal to what? And we're supposed to find the second degree polynomial. That's kind of weird. They give us some more stuff. We got p of 1 is equal to 4. P prime at 1 is 6. And then p double prime at 1 is equal to 8. Go! You can see this is why I did this problem, because it's just really weird. What is the secondary polynomial even meaning? They're saying that this is ax squared plus bx plus c. This is my answer. This is what I'm going to type in here. But obviously I need a, b, and c. And so what I'm going to find right quick is my derivatives generally. So the 2ax and the b would be left over as my slope right there. When I take my next derivative, again, just slope, I guess you could say, of this line, just be the 2a. And so what I can do is correlate these now and start to find my letters. I'm going to actually start at the bottom. So I got my 2a is equal to 8. That was it. And you're thinking, whoa, 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 what's going on here? Well, hold on. I'm saying that this is the result and this is my result, and they should be equal to one another. Now, I'm supposed to plug in x equals 1 here, but I'm going to ask you, where do I plug in an x equals 1? You don't. So there's nothing really to do there. It's almost too easy. Let me demonstrate with the next problem. So we got 2ax plus b is equal to 6. Now so again, I'm just using these two guys here. The thing is that I know that x is equal to 1, and at this point, I know that a is equal to 4. So I can start plugging that stuff in. So 2 times 4 times 1 plus b is equal to 6. And so that's going to be an 8 plus b equals 6. Move it over, and b is equal to a negative 2. Cool. And then the last one, of course, now I've got my ax squared plus bx plus c is equal to 4. Again, I already know some stuff. My x is equal to 1, my a is equal to 4, and my b is equal to negative 2, and I should be able to plug it all in. And so then what I actually have is 4 times 1 squared, negative 2 times the 1. I got a c, which I don't know yet, and then finally my 4, well, that's it. So 4 minus 2 plus c is equal to 4. These guys actually cancel, and you move this guy over. C is equal to 2. And so that's my final answer. Let me start over. Ax squared plus bx plus c should be then 4x squared plus negative 2x plus 2. And that's my final answer. You don't have to have plus and negative. You could just make it a minus, and that's okay. Well, you might be thinking here, well, I know that x equals 1. They don't want that. They want the generalized function, and that 1 was used to help me. These are specific at 1, but they want it for 2 and 3 and 4 and, well, x. So just leave x alone. Just leave x alone. That's what they want. All right, that's actually the end of that section. So thank you very much, and have a great